So we talked about real numbers. They're the numbers that we work with. Inside this group of real numbers, we can break it up into rational and irrational. Now, the rational numbers are the ones that we know what they are exactly. And any number that we know what it is exactly, we can write it as a fraction, a on b, where both a and b are whole numbers. If we can do that, then we know what it is exactly. And that's a rational number. Any number we can't do that to, such as square root of 2, right? We cannot write that as a nice neat fraction with an integer on an integer, don't know what it is exactly, then that is an irrational number. So it is anyone that can't be written. Now, irrational numbers can be expressed as unique, infinite decimals. And that's why we don't know what they are exactly, because they're infinite, but they're unique. They do not repeat at any point. Because if they repeat, as we just saw, we can turn that into a fraction. So a recurring decimal we can turn into a fraction. But if it doesn't repeat, pi, for instance, it keeps going forever and ever and ever. It might look like it starts repeating, but it then jumps out of that pattern again. We can't write it as a nice, neat fraction. So it's an irrational number. We're going to actually prove the square root of 2 is irrational. This method that I'm going to use is called proof by contradiction. And the idea is I will start with the opposite. I will assume the opposite to be true. So I'm going to assume the square root of 2 is in fact a rational number. So if it is a rational number, it must be possible for me to write it as a fraction where a and b are whole numbers, integers, and in fact have no common factors because I'll be able to cancel it down to its simplest form. Okay? So a and b are integers, no common factors. Play around with that equation there, then b root 2 must equal a. And if I square both sides, 2b squared would be equal to a squared. So therefore, a squared must be divisible by 2, because there's one of its factors. We're saying a squared is 2 times b squared. One of its factors is 2. But the thing about a perfect square is factors will always appear in pairs, because it's a square, times by itself. So if 2 is a factor, 4 must also be a factor. Okay? So any square that's divisible by 2 must be divisible by 4, because all of its primes will be there twice. So therefore, I know a squared is divisible by 4. So 2b squared, because we said that's what a squared, must be equal to 4 times some number, some whole number. I just called it k. So therefore, b squared is equal to 2k. So a squared and b squared are both divisible by 2, and therefore must have a common factor. But hang on. In my definition, I said a and b do not have a common factor. I have now contradicted myself. So a and b, they do not have a common factor. So therefore, my original statement must be false. So the square root of 2 cannot be rational. Well, if it's not rational, it's irrational. And that's what we call a proof by contradiction. Just a couple of questions there. In question number 4, it's the same sort of idea, but proving it with the square root of 3. So we can go through it and prove the square root of 3 by contradiction.